But it is Friday. I'm glad you guys are here. We've got the weekend ahead of us, but we do also have some material to cover. So we're going to get into the law of sines. I've got the law of sines written up here on the television screen. We're going to use it here in just a sec. Did we talk about my mother and Mexican restaurants?
Yeah.
Okay, so we're going to pick out of those three fractions. We're going to pick two. But there's some low-hanging fruit that Henry Howe's going to help me with first. Henry, what's the easiest thing to find in this picture? Angle C. Very good. It's going to be 50 degrees, is it not? Now, my drawing is very much not to scale because 50 and 50 means that would be what kind of triangle? It would be an isosceles triangle. Freddie. Correct. So this is a nice, easy, kind of softball, kind of soft toss kind of question for us to start with. So because we know, as Henry does, that all three angles add up to 180, and because we found that third angle to be 50, and that means, oh, these two are congruent, then you've got your isosceles triangle information from last year, and Freddie has correctly determined, oh, well, little b must be 50 as well. Okay, and that's great. It's not always going to be the case. So if, excuse me, I said 50, I meant 20. Thank you, Finley. And it's not degrees, it's just units. So good catch. So if we are going to, let's pretend like we did not know that, and we said, well, little b over the sine of 50, all right, is going to equal little c over the sine of 50. And then you're like, well, duh, okay, that makes sense why it is. So if we used our law of sines there, really that's a waste of time because you got little b over sine of 50 and 20 over sine of 50. B and 20 are the same thing, right? Because you could literally times both sides by sine of 50 and then notice, well, hey, those cancel out and you're left with b equals 20. Okay, easy peasy. Now, what's the third thing that we need to find, Blake? We're going to find little a. So we got little a over the sine of what, class? 80. And then we're going to let Aiden pick what next fraction should I use? You look like you were spaced out, and I think that is maybe showing in your answer. So first of all, if I line up my variable on top, my variable is the side. So I want to use the side over here on the top. And it doesn't matter which side I pick. They're both 20. So I'm going to have 20 over the sine of 50. And then what did we say, Sebastian, we could do to get a by itself? I want to save a little time. I don't want to have to go to the trouble of cross multiplying and then dividing again. So it's because I have cleverly listed my variables up top. Stephen, what could I multiply both sides by? We're going to times both sides by sine of 80. Everybody see that? Sine of 80. And then I got little a, and I need my calculator for this. So little a is what? 20 sine of 80, close parentheses, divided by sine of 50. Now, somebody asked this during the quiz a minute ago. That was a great question. What mode should my calculator be in? Degree mode, because those angle measures in terms of degrees, and I get 25.7 thereabouts. Okay, so 25.7. And I'm a big fan of labeling it on the picture, so 25.7. Does that work well with the fact that, hey, biggest side has to be across from biggest angle?
Yeah.
Yeah, that's a good sort of check for you to run, okay, to make sure that it's a logical answer. Jill Moore. You all right? Okay, you got to poop so bad you're dropping stuff. Goodness gracious. Now, number 3 is a good old word problem. All right, so here's what you're going to do. You're going to make a drawing based on the word problem. Okay, so the survey team measured this between point A on one side of the river and point B on the far side of the river. Okay, I got to draw a river. So, I'm definitely going to draw a river. So here's point A. Here's point B. Okie doke. One surveyor is positioned at point A. Second surveyor is positioned at point C, 65 meters up the riverbank. All right. And it says 65 meters. Okay, so that's going to be this. And then the surveyor at point A measured angle between points B and C to be 103. So I need to scoot point B up a little bit. Because that angle right there, 103. And then a surveyor at point C measures the angle between points A and B to be 42. Yeah. So we looked at this the other day when we were talking about, I don't know, it was maybe angles of elevation, angles of pressure. But look, I'm staring at Fredo, okay? And now I'm over here staring at Nash. So the angle, watch it now, even though Chillmore's got away. The angle between Nash, are you watching? Between Nash and Alfredo is 103 or whatever. Okay, so you get what I'm saying? So if I connected my lines of sight between those two boys, then the angle between, I am the vertex. And so when it says, hey, the surveyor at point C, that means that C is the vertex and the angle that he's looking at his two lines of sight. Now, what scenario do we find this in? This is angle, side, angle. So Christian, what's the low-hanging fruit, easy thing to find here? Very good. And does anybody know what it is? Are you tearing up my pencil sharpener? Oh my goodness. It's called user error. Get out of the way. You want me, Jay?
Yeah.
That's okay. He refused my help. He's a teenage boy. Teenage boys don't want help. All right. So what is it that they're asking me to find? Find the distance between point A and B. So that's little c. All right. So Phil, set me up a nice equation to solve for little c. We're going to the Mexican restaurant. We're picking 2 from our law of science. Good. Do y'all notice how he paired? I like that. He paired up the top and the bottom. Those letters match. So little c on top means I got to use big C on bottom. And then give me one more. Would it be smart to use unknown little a and 103? Why not? Because you'd have one equation and 2 unknowns, and that doesn't help anymore. So what's your next fraction you're going to use? Speak up. Help him out, Michael. 65 over the sine of 35. So the way that I've got this written up is I've got little c on top. So over here I want little b, which happens to be 65. And then instead of cross multiplying, Andrew, what do we say we could do in this case? That is correct. Multiply both sides by sine of 42. And at this point, just plug and chug into the calculator. I'm bored. Anybody got a number for me? 55.8? 75.8. Beautiful. 75.8. Thereabouts. So we've answered the question. And that's meters. If you wanted to be all scientific and whatnot, you could put meters. What's the problem? Do we have disagreement on the answer? Oh, gotcha. Well, that's helpful too while you're studying in a group, like especially when you guys go to college and you got like these group study sessions, so that if you're just one dude by himself and you put it in wrong and you're like, oh, that's the right answer, you don't have anybody to call you on it. Okay, so like in a class scenario, that's great. Any questions on the easy part of law of science? You will have 10 of these problems on Delta Math over the weekend. Okay, that's not it. Angle, side, angle is the same thing.
Angle, side, triangle.
Angle. Oh, we just had angle, side, angle, didn't we? Yeah, we had angle, side, angle. And Nicholas, I'm gonna get you in just a sec. But we started off. We had angle. Did we also have angle, side, angle? Angle, side, angle. You can have angle, angle, side. It's the same thing because you're still finding that third angle. And then Efkeman, what did you think he meant? In that word problem, I think they were just asking for find the distance between points A and B. Blake or Franklin, I thought I saw him. Blake. Dun dun dun.
Lion.
Isn't that a scary looking lion?
Lion.
You think that's an not HA, you think that's an AI lion?
No, I know.
I put this up back in 2015. They didn't have AI back then.
I am the lion.
Dude, if I saw that coming for me, I would be scared.
Awesome. I could lay down. Big cat. Faucet would.
Yikes. Okay, so angle side side is probably the hardest thing that you'll do in trigonometry this year, but don't be screwed. Don't be screwed. All right, so what I'm going to do is I'm going to give you some best practices. I'm going to teach you how I recommend that you approach this process. Right? We got to understand what the word ambiguous means. Did we talk about that the other day? All right, give it to me. Could be this way, could be that way. Okay, it's kind of left up in the air. So angle side side, okay, is the ambiguous case. You're going to remember that because that's the naughty word and it's the scary one. And there you go. Angle side side. I highly recommend, I said this at the beginning of class, that you put your given angle in the bottom left. You make the base horizontal, and then you just rock it around there, angle, side, side. And by the way, we know that the big A or big B or big C, whatever the letter is going to match his side that's across from him. So if you're given big B, then you're going to put big B in the bottom left and little b in the top right. Okay? That's how you're going to draw it out. We've already practiced that. So let's take a gander at, whoops, I got to delete these. Delete, because this is last year's stuff. Wait a minute, what was that? Oh, we had a discussion last year, I guess. Okay. So I guess I looked up an angry bear, an angry tiger. That looks fake. That tongue is too pink. Okay, we'll do a quick vote. I got to turn the lights off so you can see. No. You know what I'm going to ask. Yes, Fred?
I think you were trying to figure out which one got the strongest side.
Well, okay, so here's what I want to ask. Which would you rather get attacked by? Okay, which would you rather get attacked by? Raise your hand if you'd rather get attacked by the lion, big scary lion. All right, raise your hand. How many of you would rather get attacked by the big scary bear? How many of you would rather get attacked by the big scary tiger? The ginormous silverback? And all of y'all are sharp? What the heck is wrong with y'all? I wouldn't pick the shark. Ugh. Have y'all not seen Jaws? No, I'm sorry. I should have prefaced the question. You are going to die no matter what.
The tiger. The bear.
I'm like, okay, the shark is going to nibble on you, and you're going to have a painful, excruciating fall. No good.
Tiger's gonna rip you.
You think the tiger will get you the fastest?
The bear. No, I know.
Oh, yes.
The cat.
One of the cats.
How did I get a cat go to your neck? Go.
All right, Freddie, you got something to weigh in on, Freddie?
Hold on. Be respectful. Be respectful. It's the only one that can only move forward. Our one can move back.
Yeah, that's true. That's true.
Get behind.
I'll take two more comments. I'll get Blake and Christian.
All you gotta do is just put the shark over.
Oh, yeah.
Just let him out. Right on that. I'll say, I could use my favorite swim stroke to like. All right, and then Christian. Fighting the gorilla? Okay. I think you and I have different definitions of fun. That's what I think. All right. Probably the tiger. Probably the tiger. I think it would be quick and painless. I think it would be just like punch, I'm dead. Good. All right, enough silliness. Do we all understand that this is angle side side here? Yeah. All right, this is a stupid question. How do I know it's angle side side? Well, hold on. How do you know it's not side? Side angle side is a sandwich. Side angle side is, are you listening? Is a sandwich. This is not a sandwich. This is angle side side. Okay. And so when you run around the horn there, you know it's angle side side. You know it's going to be the ambiguous case. Now, here is the problem. Okay. I'm thinking of someone in here right now that has brown hair and is wearing purple outerwear. I'm thinking of somebody that has brown hair and is wearing purple outerwear. Now, what, BJ, what's the problem with my description there? It's too ambiguous. It could be Freddie. It could be it could be Michael, or it could be Andrew. Mike's got brownish hair. All right, but you get what I'm saying? It's like the notion of my description was that it left room for multiple possibilities. That's what this does right here. Now you might be like, Coach Maury, you're full of crap. That is the only possibility. Okay. Well, if you think that, then how about this? Right there. Right? To where, again, did I have angle, side, side? Yeah, but I drew a different triangle. I took that 12 and I swung it back like a pendulum and I lined it up over here. So it could have been an acute triangle, or it could have been an obtuse triangle. We don't know until we dive in and we run some numbers. Okay? So the notion of the ambiguous case is it could be maybe there's a couple of possible triangles. Or you know what? Oh, I'd love to see that, please. Okay, let's go and find it. Who are you standing your finger at in there? Nicholas, would you look at the Spider-Man drawing one? Yeah, that's. I love Spider-Man. You know, Teddy and I watched Homecoming again the other day. We love Homecoming. Homecoming is my favorite Spider-Man movie.
What's your favorite?
Steve asks, do you not like Homecoming?
No, it's just like Andrew Garfield.
Do you have a different one? You like Andrew Garfield?
Andrew Garfield's
I'm not an Andrew Garfield guy.
They're just like the best like graphics and like.
And I do like Emma Stone in those movies as Gwen, but as far as the plot goes, I like Homecoming better. All right, back to math. Blake. All right, so here's what we're going to do. We're going first of all, we got to go to the Mexican restaurant, pick two. Which two are we going to involve? We're going to have to involve A, because we know both parts of that. The sine of 33 over 12. And then I can't pick C because that goes back to what Phil said a minute ago. I don't know either one of those. That's two variables in one equation. Can't do anything with it. So we must therefore pick the B. And so we'll do sine of big B over 19. You got what? You got 60 what? Oh, so Mitchell found an angle. And Michael Estep, how do you think Mitchell went about finding that angle? What do we use to find angles? It's a general question. Inverse trig functions. Very good. Very good. Finley, you gonna be okay? Yeah. Inverse trig function. So in other words, we multiply both sides by 19. By the way, did you notice how I cleverly flipped both fractions so that my unknown was up top? And that saved me the trouble of having to cross multiply and divide. So now I've got the sine of B. So that means that B will equal the inverse sine of whatever that number is. 19 sine 33, all divided by 12. All right, and I do want to show this on the calculator. All right, so we're going to do inverse sine. What mode should I be in? Good. 19 sine 33 close. 12. And we got 59.9. What mode you in? And let me see how you type it in. Oh, you do inverse sign of that. So you hit second sign and then your.
Wait, you don't divide by 12, you do inverse sign first and then you divide by 12?
Well, we're taking the inverse sign of that whole left-hand side. So like this is, hey, can you sit down and be quiet? And what's wrong with your foot? I'm not mad at you, but I'm going to make a play on words here. I'm getting irritated. You said your foot was irritated. I'm getting irritated. No, that fell flat. No. Okay, so Michael Davis had brought up a great point. This is some number. I think he said it was like point something or other, right? That's some number. What we're doing is we're taking the inverse sign of that number to figure out the angle. And Gilmore, what did we say our angle was? 59.6. Okay, now this is where you really got to pay attention. Please lock in. Make sure you hear me on this. Because remember the ambiguity? We said, well, okay, maybe there's no possible triangle. Right? Let me, okay, I didn't do this, but suppose I'm thinking of a kid in here that's he's wearing purple outerwear, he's got brown hair, and he's 8 feet tall. Nobody. You know what I'm saying? Even Freddie, we love Freddie, he's tall. But he ain't 8 feet tall. Okay, so like sometimes you're given angle side, and it doesn't even describe a triangle. Okay, if that is the case, what you're going to find right here is an angle that leaves not enough room for a third angle. Do we have enough room for a third angle? Okay, what would that third angle be then? Are you for real on that? 87.4? All right, do you guys concur with that?
Yeah.
Okay, so is that a legit triangle? Of course it is. All right, now, again, we can now throw out the scenario of the 8 foot tall person, right? We know this is a legit triangle because we've got 3 angles and it's good to go, okay? But who is to say that maybe I can't swing that 12 degrees to this other side and get 2 different angles, okay? Now, the way that we're going to do this, and this is what we're going to kind of wrap up class with today, is that we've got, this is one legitimate triangle right here. What's the only other thing that I would need to find? Little c, okay? But I wonder if it's possible for this to be a different b value. Are you packing up already? Well, okay. If I were to swing it to the other side, do you see how these two would be congruent? So what would the relationship between this obtuse angle and the b that we found, what would that relationship be? It's an S word. They are supplementary. What's the supplement to 59.6? How about 120.4? Okay. Does that leave enough room for a third angle? Try again. Because all 3 angles add up to what? 180. So can we be like Kenneth and give me that? Is it 26.6?
Yeah, right.
Okay. So now this is a complete different scenario. A, C, B. Little c right there. Okay. So what I mean by that is this initially, this angle C was not locked in, so it could swing like a pendulum. Now it doesn't have to be 87.4 degrees. It could, maybe this 12 could stretch down here. You know what I mean? And so that's like, it could have described Denegri, or it could have described Roberts, or it could have described Johnson or Davis. You know, that description was ambiguous. And so now you have to line up with this bottom right-hand angle. You have to line up and say, is there enough room for a third angle? And if so, then I've got 2 possible scenarios. This is an example where there's 2 solutions. You guys remember how sometimes you get a problem that has 2 solutions? You draw, I don't know why, nobody told us the class is over. I've got 2 minutes and 15 seconds. Stop moving around and packing up. Andrew, you're fine.
I'd be fine.
Okay, this is important. It's the supplement of that angle. Because if I swing it over here and I create that isosceles triangle, those 2 base angles would be congruent, and therefore this and that would be supplementary. Like,
How would you understand this?
All right, so the test that you run, no pun here intended, hinges upon your answer for this bottom right-hand corner. Remember how I told you to set it up the right way every time? Put your angle in the bottom left. So the angle that you find the bottom right, that's across from one of those given sides, okay? If this angle leaves enough room for a third angle in the initial drawing, then you know you've got at least one triangle. Then if his supplement also leaves enough room for a third angle, then you've got two possible scenarios. If it doesn't, like if this was so big that we didn't have enough room for a third angle, we would throw that scenario out and we'd say, this is the only one. Eli's got his hand up. Yep. Kevin. No, it varies. It depends. Like you'll see some as we go through this lesson, you'll see some where this one has no solution, no possible triangle. And we'll have to get into that on Monday. But the idea is I have to explore. I have to draw it out, run the numbers, and see about the supplements. Ready? Subtract 180 minus the given angle. You did inverse sine right here. So which one do you rate? So we're going to do 19 regulars. Hey, look, what have you got due for me next week? Delta math. That's math.
This number. I didn't know that much. It's just like you do. No, I think I've got. Valid question, but it's not watch. Nobody.
There is a much more. I promise you, backstroke is nowhere near. Oh.
When he says it is, well, I don't.
Please. Ew.
Billy Brown.
Here we go. So for now,
AX squared plus BX plus B.
And then you have a BS, B, and you have an inverse of B, so you have X equal, and you have pressure on top of it. Say it's positive B, it's negative B, if it's negative B, then it's positive B. Yeah, then, so whatever B is, whatever sign it is. And you have it be plus or minus square root of B squared minus or AC. And on the bottom part, you have 2A, and we have to see. You can figure something out. Did you all see on the Delta map, there's like some questions where you had, where you had the square roots, you got that, but then you can take out, and then some of them, at save the denominator, it takes out the numerator. Let's say 10 plus or minus. This morning, I'm done. There's one question, over some questions, I forget what section it was in, was like, if we get the square roots, but it doesn't, factor out or anything like that, you can't, and it's in perfect square, it has, like 8, yeah, 4 at the top, and 4 minus 2 square root 2, or 4 minus 2, like 49, something like that. And you had a 2 at the bottom, what it did was it like.
You want to cancel those twos out.
So what you mean, I'm confused.
That's okay. I'll show you. So suppose I'll make something up here. Six plus or minus 2 square root of 3 over 10. Equation. Okay. Now this is an example that needs to be simplified. You would factor a 2 out from the top.
3 equals or plus.
Oh, you have that
Yeah, then.
Yep. And then you cancel a 2. And that's 100% what you get.
And then you
So
have.
it has to be common to both these terms.
Plus minus
Back it out.
radical.
If we're around, if we were at like 2 plus, let's say it's quick to find out. Where.
One word.
Yeah, negative.
Like, you just leave it as it. Yeah, if I can't make it out from both of them, Wes, then I'm not allowed to cancel it out.
AX plus, AX squared plus BX plus C equals 0. You have to make that equal to 0. Then you have that.
You ready, Mr. Morgan? You ready?
Negative.
Listen.
You have that be positive, you have X equals, numerator, if B is positive, it's negative. If B is negative, it's positive. I know. Then you have plus or minus square root B squared.
What you got, Chuck?
Minus 4.
Alright, negative b plus minus square root of b squared minus 4ab over, AC over 2a.
All right, what about the preface? What about the first part?
I know.
The preface?
AX squared plus BX plus C.
Well, yeah.
Good.
I knew
You
that.
gotta know both those parts.
Okay.
You may, make it quick. Hey, we're gonna have a little quiz, a memorization quiz on, do you know your quadratic formula? That's gonna be the first thing we do right out the gate. So the bell's gonna ring in about a minute. And y'all can keep your desk cleared except for a clean sheet of paper. Nothing written on the sheet of paper, not anything at all. Yeah, half sheet, please. Hello.